Welcome students. Today's topic is about unit operations in food processing. The main objectives covered under this topic includes: number first, to provide general introduction of unit operations in food processing, to acquaint students about principles of different unit operations in food processing, to acquaint students about applications of unit operations in food processing, to acquaint students about equipments used in different food processing operations. Unit operations are the process involved in converting a raw product to the final product that's consumed by the end users. Important unit operations in the food industry are heat transfer, drying, evaporation, contact equilibrium processes, which includes distillation, extraction, gas absorption, crystallization, and membrane processes. Mechanical separations, which include filtration, centrifugation, sedimentation and sieving, size reduction and mixing. The combination and sequence of operation determines the nature of the final product. Number first, cleaning. Cleaning is the unit operation in which contaminating materials are removed from the food and separated to leave the surface of the food in a suitable condition for further processing. All food raw materials are cleaned before processing. The purpose is obviously to remove contaminants which range from innoxious to dangerous. There are a number of cleaning methods available, classified into dry and wet methods, but a combination would usually be employed for any specific material. Dry cleaning methods. The main dry cleaning methods are based on screens, aspiration or magnetic separations. Dry methods are generally less expensive than wet methods, and the effluent is cheaper to dispose of, but they tend to be less effective in terms of cleaning efficiency. Wet cleaning methods. Wet cleaning methods are necessary if a large quantities of soil ought to be removed, and they are essential if detergents are used. However, they are expensive as large quantities of high purity water are required and the same quantity of dirty effluent is produced. Number second is peeling. Peeling of fruits and vegetables is frequently carried out in association with cleaning. The various methods used for peeling are: live peeling includes the use of 1 to 2% alkali solution that can be used to soften the skin, which can be removed by water sprays. Mechanical knives are suitable for peeling citrus fruits. Flame peeling is useful for onions, in which the outer layers are burnt off and charred skin is removed by high pressure hot water. Number third is size reduction. Size reduction is commonly known as cumination, that is the unit operation in which the average size of solid pieces of food is reduced by the application of grinding, compression or impact forces. When applied to the reduction in size of globules of immiscible liquids, for example oil globules in water, size reduction is more frequently referred to as a homogenization or emulsification. Different methods of size reduction are classified according to the size range of particle produced. Number first is chopping, cutting, slicing and dicing. It includes large to medium, for example stewing steak, cheese and sliced fruit for canning. Number second is medium to small, that includes bacon, sliced green beans and diced carrot. Number third is small to granular size, which includes minced or shredded meat, flaked fish or nuts and shredded vegetables. Milling to powders or pastes of increasing fineness. Number third is emulsification and homogenization, for example mayonnaise, milk essential oils, butter, ice cream and margarine. Now filtration. Filtration is the removal of insoluble solids from a suspension, usually feed slurry, by passing it through a porous material or filter medium. The resulting liquor is called the filtrate and the separated solids are the filter cake. Filtration is used to clarify liquids by the removal of small amounts of solid particles, for example from wine, beer, oil and syrups. When a suspension of fine particles is passed through a filter, the first particles become trapped in the filter medium and as a result that reduces the area through which the liquid can flow. This increases the resistance to fluid flow and a higher pressure difference is needed to maintain the flow rate of filtrate. Number 6 is forming and mixing. Mixing or blending is a unit operation in which a uniform mixture is obtained from two or more components by dispersing one within the other. The larger component is sometimes called the continuous phase and smaller component by dispersed phase by analogy with emulsions, but these terms do not imply emulsification when it is used in this context. Mixing has no preservative effect and is intended solely as a processing aid or to alter the eating quality of foods. Examples include texture development in dough and ice cream, control of sugar crystallization and aeration of batters and some chocolate products. Forming is a size enlargement operation in which the foods have a high viscosity or a dough-like texture that are molded into a variety of shapes and sizes, often immediately after a mixing operation. It is used as a processing aid to increase the variety and convenience of baked foods, confectionery and snack foods. It has no direct effect on the shelf life or nutritive value of foods. Extrusion has also a foaming function. Number 7 is pasteurization. Pasteurization is relatively mild heat treatment in which the food is heated to below 100 degrees centigrade. In low acidic foods whose pH is less than 4.5, for example milk, it is used to minimize possible health hazards from pathogenic microorganisms and to extend the shelf life of foods for several days. In acidic foods, usually pH less than 4.5, for example bottled fruit, it is used to extend the shelf life for several months by destruction of spoilage microorganisms like yeast and molds or by enzyme inactivation. In both types of food, minimal changes are caused to the sensory characteristics or nutritive value. Processing containers of food, either which have a naturally low pH, for example fruit pieces, or in which pH is artificially lowered, for example in case of pickles, is similar to canning. It is often termed as pasteurization to indicate the mild heat treatment employed. Some liquid foods, for example beers and fruit juices, they are pasteurized after filling into containers. Metal or plastic containers are processed using steam air mixtures or hot air as there is a little risk of thermal shock. In all cases, the food is cooled to approximately up to 40-degree temperature and in order to evaporate surface water and therefore to minimize external corrosion to the container or cap and to accelerate setting of label adhesives. Number 8, heat sterilization. Heat sterilization is the unit operation in which foods are heated at a sufficiently high temperature and for a sufficiently long time in order to destroy microbial and enzymic activity. As a result, sterilized foods have a shelf life in excess of 6 months at ambient temperatures. In heat sterilization, it is important to ensure that the food is adequately heat treated and to reduce post-processing contamination. The food should then be cooled quickly and it may require refrigerated storage or should be stable at ambient temperature. The heating process can either be batch or continuous. In all thermal processes, the aim should be to heat and cool the product as quickly as possible. Next is evaporation. Evaporation is commonly known as concentration by boiling, and it's a partial removal of water from the liquid foods by boiling of water vapor. It increases the solid content of a food material and hence preserves it by a reduction in water activity. Evaporation is used to pre-concentrate foods, for example, as in case of fruit juices, milk and coffee, prior to drying, freezing or sterilization, and hence it reduces their weight and volume. This saves energy in subsequent operations and reduces storage, transport and distribution costs. There is also a great convenience for the consumer, for example, fruit drinks for dilution, concentrated soups, tomato or garlic pastes and sugar. Now, distillation. Although common in the chemical industry, distillation in food processing is mostly confined to the production of alcoholic spirits and separation of volatile flavor and aroma compounds, for example, production of essential oils by steam distillation. When a food that contains components having different degrees of volatility is heated, those that have a higher vapor pressure, for example, that are more volatile components, are separated first. These are termed as the distillate, and the components that have a lower volatility are termed as bottoms or residues. In order to enhance the separation of these components and equilibrium conditions between the liquid and vapor phases, a proportion of the distillate is added back to the top of the column, and a portion of the bottom is vaporized in a reboiler and added to the bottom of the column. Columns are filled with either a packing material that is typically made up of ceramic, plastic or metal rings, or fitted with perforated trays, both of which increase the contact between the liquid and vapor phases. Next, dehydration. Dehydration or drying is defined as the application of heat under controlled conditions in order to remove the majority of water normally that is present in a food by evaporation, or in case of freeze drying it is called as sublimation. This definition excludes other unit operations which remove water from foods, for example, mechanical separations and membrane concentration, evaporation and baking, as this normally removes much less water than dehydration. Dehydration is usually described as a simultaneous heat and mass transfer operation. Sensible and latent heat must be transferred to the food in order to cause the water to evaporate. Placing the food in a current of heated air is the most widely used method of supplying heat. The heat is transferred by convection from the air to the surface of the food and by conduction within the food. Alternatively, the food may be placed in contact with a heated surface. The heat is transferred by conduction to the surface of the food in contact with the heated surface and within the food. There is limited use of radiant, microwave, radiofrequency energy in dehydration. Examples of commercially important dehydrated foods are coffee, milk, raisins, fruits, pasta, flours including bakery mixes, beans, pulses, nuts, breakfast cereals, tea and spices. Next is baking and roasting. Baking is the unit operation in which heated air is used to alter the eating quality of foods. Baking is a term commonly applied to the production of cereal-based products such as bread, biscuits, cakes, pizza, etc. And in English usage, baking is generally applied to the production of fermented bread. Baking is at heart a process, the conversion of some relatively unpalatable ingredients such as starch, gluten, bran in case of some cereals into the aerated, open, cell sponge structure we know as bread has taken millennia to develop. Baking involves simultaneous heat and mass transfer. Heat is transferred into the food from hot surfaces and air in the oven, and moisture is transferred from the food to air that surrounds it and then removed from the oven. Frying. Frying is a unit operation which is mainly used to alter the eating quality of a food. A secondary consideration is the preservative effect that results from thermal destruction of microorganisms and enzymes, and a reduction in water activity at the surface of the food or throughout the food if it is fried in the thin slices. The shelf life of fried foods is mostly determined by the moisture content after frying. Foods that retain a moist interior, for example, donuts, fish and poultry products, which may also be breaded or battered, have relatively short shelf life owing to moisture and oil migration during storage. These foods are important in catering applications and are produced on a commercial scale for distribution to retail stores, preserved by chilling or by gas packing. Next, chilling. Chilling is the unit operation in which the temperature of a food is reduced to between -1 degree centigrade and up to 8 degrees centigrade. It is used to reduce the rate of biochemical and microbiological changes and hence to extend the shelf life of fresh and processed foods. It causes minimal change to sensory characteristics and nutritional properties of foods, and as a result, chilled foods are perceived by consumers as being convenient, easy to prepare, high quality and healthy, as in case natural and fresh. Chilling is often used in combination with other unit operations, for example, with fermentation or pasteurization in order to extend the shelf life of mildly processed foods. Chilled foods are grouped into 3 categories according to their storage temperature range as follow. Number first is from -1 degree centigrade to +1 degree centigrade. For example, fresh fish, meat, sausages, groundnut meat, smoked meats and breaded fish. Number second category is from 0 to +5 degree centigrade. That includes pasteurized canned meat, milk, cream, yogurt, prepared salads, sandwich, baked goods, fresh pasta, fresh soups and sauces, pizza, pastries and unbaked dough. Number third category includes from 0 to 8 degree centigrade. That includes fully cooked meats and fish pies, cooked or uncooked cured meats, butter, margarine, hard cheese, cooked rice, fruit juices, soft fruits and so on. Freezing. Freezing is the unit operation in which the temperature of a food is reduced below its freezing point and a proportion of the water undergoes a change in the state to form ice crystals. The immobilization of water to ice and the resulting concentration of dissolved solutes in unfrozen water lower the water activity of the food. Preservation is achieved by a combination of low temperatures, reduced water activity and in some foods pre-treatment by blanching. The major groups of commercially frozen foods are as follow. Number first, fruits, that include strawberries, oranges, raspberries, blackcurrants, either whole or pureed or juice concentrate. Number second includes vegetables like peas, green beans, sweet corn, spinach, sprouts and potatoes. Number third category includes fish fillets and seafoods, for example, cod, plaice, shrimps, crab meat, including fish fingers, fish cakes, prepared dishes with an accompanying sauce. Number fourth category includes meat like beef, lamb, poultry as carcasses, box joints or cubes, or meat products like sausages, beef burgers and reformed steaks. Number fifth category includes baked goods like bread, cakes, fruit and meat pies. Number fifth category includes prepared foods like ice creams, desserts, complete meals and cool freeze dishes. During freezing, sensible heat is first removed to lower the temperature of a food to the freezing point. In freshly foods, heat produced by respiration is also removed. This is termed as the heat load and it is important in determining the correct size of a freezing equipment for a particular production rate. A substantial amount of energy is therefore needed to remove the latent heat and form ice crystals, and hence that is used to freeze the foods. The latent heat of other components of the food, for example in case of fat, must also be removed before they can solidify, but in most of the foods, the other components are present in smaller amounts and removal of a relatively smaller amount of heat is needed for crystallization to take place. Next is freeze drying. It is commonly known as sublimation drying or lyophilization of solid foods. This method of drying foods was first used in industry in 1950s. The process involves three stages. Number first is freezing the food material, then subliming the ice, primary drying, and then removal of the small amount of water bound to the solids, that is commonly known as secondary drying or desorption. Freezing may be carried out by any of the conventional methods including blast, immersion, plate or liquid gas freezing. Blast freezing in refrigerated air is most oftenly used. It is important to freeze as much of the water as possible. This can be difficult in case of the material with high soluble solid contents such as concentrated fruit juice. As the water freezes in such a material, the soluble solid contents of remaining liquid increases and so as its freezing point is lowered. At least 95% of the water present in the food should be converted to ice to attain successful freeze drying. Ice will sublime when the water vapor pressure in the immediate surrounding is less than the vapor pressure of ice at the prevailing temperature. Next is extrusion. Extrusion is a process which combines several unit operations that includes mixing, cooking, kneading, sharing, shaping and forming. Extruders are classified according to the method of operation, that is cold extruders or extruder cookers, and the method of construction, whether it is a single or twin screw extruder. The principle of operation are similar in all types. Raw materials are fed into the extruder barrel and the screws then convey the food along it. Further down the barrel, small flights restrict the volume and increases the resistance to movement of the food. As a result, it fills the barrel and the space between the screws flight and becomes compressed. As it moves further along the barrel, the screw kneads the material into a semi-solid plasticized mass. If the food is heated above 100 degrees centigrade, the process is known as extrusion cooking or hot extrusion. A variety of shapes including rods, spheres, donuts, tubes, strips, quills, shells can be formed. Typical products include a variety of low density expanded snack foods, ready to eat, puffed cereals. Next process is coating or enrobing. Coating of batter or breadcrumbs are applied to fish meats or vegetables. Chocolates or compound coating are applied to biscuits, cakes, confectionery, and coatings of salt, sugar, flavorings or colorants are also applied to the snack foods. Baked goods and confectionery. In each case, the aim is to improve the appearance and eating quality of foods and to increase their variety. In some cases, coatings are also provide a barrier to the movement of moisture and gases and to protect the food against mechanical damage. Coatings are also applied to foods to improve their appearance, to modify texture, to enhance flavors, to improve their convenience, to increase variety and add value to basic products. Next is packaging. Packaging is an important part of all processing operations, with some, for example, canning and modified atmospheric packaging. It is integral to the operation itself. Packaging may be defined in terms of its protective role, as in packaging is a means of achieving safe delivery of products in sound condition to the final user at a minimum cost. The functions of packaging are: number first is containment, that is used to hold the contents and to keep them secure until they are used. Number second is protection against mechanical and environmental hazards encountered during distribution and use. Number third is communication, in order to identify the contents and assist in selling the product. Shipping containers should also inform the carrier about the destination and any special handling or storage instructions. Some packets inform the user about the method of opening or using the contents. Machinability. Machinability to have a good performance on production lines for high speed filling, closing and collating, that is 1000 packs per minute or more without too many stoppages. Convenience. Convenience throughout the production, storage and distribution system, including easy opening, dispensing and after use retail containers for consumers. Next is material handling. Efficient material handling is the organized movement of materials in the correct quantities to and from the correct place, accomplished with a minimum of time, labor, wastage and expenditure and with maximum safety. When establishing methods for material handling, a system approach that covers raw materials and ingredients in process stock and distribution of finished product to consumers is needed. This creates optimum flow of materials in the correct sequence throughout the production processes and avoids bottlenecks or shortages. This area is known as production planning. In summary, correct production planning should ensure that raw materials, ingredients and packaging materials are scheduled to arrive at the factory at the correct time, in the correct quantities and in the correct condition. Storage facilities are sufficient for the anticipated stocks of materials and are suitable to maintain the quality of material for the required time. Handling equipment has sufficient capacity to move materials in the required amounts. Staff levels are adequate to handle the required amounts of materials. Processing and packaging equipment is selected to provide the required production throughput. Finished product warehousing is sufficient to accommodate stock levels, taking into account both production and sales volumes. Distribution vehicles are sufficient in number and capacity, and journeys are scheduled to optimize fuel consumption and drivers' time, particularly minimizing journeys with empty vehicles. With this, we conclude today's topic. Hope you understood well.